If you are watching this video, that means that you have decided that you are going to work on a sinusoidal function project that's talking about daylight hours across the United States. So let's go over a few things that we're going to do first. What you're going to do is you're going to choose places that are far apart, but make sure that you are choosing cities that are on the same longitudinal lines. So let's talk about what that means really quick. Longitudinal lines are the lines that go up and down around the equator. Just like in physics, if a line is to the west of the prime meridian, so that means to the left, it will be negative. If it's to the east, it'll be a positive. So for example, most of the cities, the prime meridian runs through London and the UK. So most of the cities in the US will have a negative longitudinal line because they lie to the left of Europe. So what we're going to do is we're going to choose 3 cities that all lie within the same longitudinal line. So if my longitudinal line was 80 degrees west or negative 80, I would choose 3 cities that lie along this line. So it looks something like what? Like Miami, Washington, D.C., maybe something up here in Canada. Moving down here, we might choose Panama or something similar in order to get 3 cities that are on the same longitudinal line. Now, you do not have to do those same things. We are asking that you choose 1 in Canada, 1 in the United States, and then 1 anywhere else. It can be Canada or the United States as well, or you can go down south of the equator. So let's talk about what this means. Moving back to our original document, there's a website right here that will help you find longitudinal and latitudinal lines of various places. So if I click on this website and go to it, as you should be doing, you're going to type in your first city of choice. I chose Toronto as my city. You have to choose somewhere different than this for your Canadian city. But if I'm choosing Toronto, very similar to what we said before, if they're on the same longitudinal line, it'll probably be any city that falls within here. So when I click on, or when I search Toronto, Canada, I see that it's near longitudinal line negative 80. So what you're going to do is you're going to go through and you're going to look at these lines here, and you're going to pick a city in the United States, a city in Canada, and then anywhere else, but they need to all be nearing that same longitudinal line of negative 80. So for example, I could choose Wilmington, North Carolina, because it's on that longitudinal line, but a different latitude. Latitude is going to be east and west. I could choose, what else could I choose? I could choose Orlando, Florida. Looks very similar to the same longitude. And scrolling down, looks like I can find a few more. I could choose Ecuador, or I could choose the city in Peru, and they're all on that same longitudinal line as Toronto. So what you're going to do is you're going to find your 3 cities. So 1 in Canada, 1 in the United States, 1 anywhere else. I do not care what the latitude is, but make sure that the longitude is all very similar. If you want to say negative instead of west, that's fine. After you've decided what your 3 cities are by that batch geo, what you're going to do is you're going to go to the solar day length website, and it should bring up a day length sunrise and sunset calculator. After you get to this website, you should be able to type in your cities. So for example, mine is Toronto. And what I can do here is I can go over to this configuration calendar on the left and put in any day, and we're going to try to correspond those to the days of the table. So your table will be blank. Mine is already filled out. But what I will do is I'll say, okay, what happened on January 30th? How much sun was there? This says 9 hours and 45 minutes. So then you're going to go to your table and you're going to fill out the number of hours that correspond. If I were to go to April 30th, it says there were 14 hours and 5 minutes. Remember that this 5 is out of 60, and so in order to truly calculate what that decimal point was, I would need to say 5 divided by 60. right? And I would get 0.0833, which rounds up to 14.1. So you're just filling out this calculator for all these different days. So April, let's go to May 30th. We have 15.07, so similar thing, pulling out your calculator, you could have tracked that down, that rounds to be about 15.1. So you're going to go through and fill out this table of values for all three of your cities. After you have that done, the next thing that you're going to do is you're going to graph your data. Now, you can do this a few different ways, either very neatly on a piece of paper, or you can do it on Desmos, and then you can submit screenshots of your graphs into your work. So if I go to this graph that I created for Toronto, and if you use Desmos, you're more than welcome to use my graph. When you click on that graph, what should happen is it should open up my graph of my Toronto values. So all of these values in this table were values that I gained from using this daylight calculator for these specific days. So this would be, for example, January 1st, right? 0 days passed. And then we're moving on to 30 days past, 60 days past, 90 days past, moving through the months. So after we have this information inputted, what you're going to do is change this for your own. And the way you're going to do that is by clicking on the graph, and you can rename it. So let's say your second city, or my second city was Orlando. I can duplicate the graph and press save. Then on this on these 3 bars right here on the left, I can click that and I can find your other graphs without making edits to my original function. After you do that, all you're going to be doing is going through and manipulating these values according to the ones you determined. Now you'll notice that I also have 4 points labeled according to my directions, and that's spring equinox, summer solstice, fall equinox, and winter solstice. These X values will never change. And the reason these X values never change is because we know spring equinox always happens on March 21st. We know summer solstice always happens, I forgot when it happens, on June 21st, September 21st, and December 21st. These output values will change though according to the city that you are calculating for. So these values right now are for Toronto, but if I'm changing all my values towards Orlando, I might type in Orlando. And then let's see what happened on March 21st. It says that my day length for Orlando was 12 hours and 8 minutes. So I would manipulate this guy right here for spring equinox in order to correspond to that value. I would also be manipulating all of these Y values or all these outputs to correspond with Orlando times.